Yes, so our today's topic is differentiation, and our core business in differentiation is to get gradient functions, and these gradient functions, their major importance is to help us get the gradient of a line at any given point or of a curve at any given point. So it is very important to know how to differentiate so that you are able to get what we call gradient function or the differential that is normally given by dy over dx, basically to mean change in y over change in x. It represents the rate at which y changes with respect to x. Okay? So how do we do differentiation? Differentiation, for example, when you are given a function y is equals to x raised to power n. When you want to differentiate, in order to get the gradient function or the differential, number one, you are going to pre-multiply the unknown by the power. Number two, you are going to reduce the power by 1. What do I mean? If I want to get the differential or the gradient function of this line, I'm going to say dy over dx is equals to, I'm going to pre-multiply this. This unknown, I'm going to pre-multiply it by the power. So I'm going to get nx. Good. And then what happens to the power after you pre-multiply? We reduce it by 1. As simple as such. An example is, if you are told to get the gradient function of this line, y is equals to 3x squared, how do you differentiate? You just say dy over dx is equals to, you multiply this by this, you get 6, and you get x. Because we are going to reduce this by 1, so x is going to remain as 1. Another example, you can be told that y is equals to, for example, negative x cubed plus 2x minus 3. How do we differentiate this now? We say dy over dx will be, so you differentiate each individually. So this is like 3 times negative 1. So that will be negative 3x. Then you reduce this by 1, so it becomes squared, then plus. Remember 2x is like 2x raised to power 1. So when you multiply this by this, it becomes 2. Then when you reduce the power, it becomes, if you reduce it, it becomes 1 minus 1, which is 0. And you know any number raised to power 0 is 1. So this is going to be our differential or our gradient function. Why this 3 does not appear is because negative 3 is like negative 3x raised to power 0. So when you multiply 0 by a negative 3, it nullifies everything. So it does not form part of our differential. Okay? Yes, so once you know how to do that, then you're very much good to go. It means when you're given any equation, you can get its differential. Or even if you're given the equation y is equals to, for example, mx raised to power n. You just know you're going to have dy over dx is equals to mn. You pre-multiply, then you reduce the power by 1. It is the same thing we were doing there. If you're given y is equals to, for example, 5x cubed, that is what you do. You say dy over dx is equals to 15x squared. So that is entirely what you do. So why are we struggling to find the dy over dx? It's because this one will help us get the gradient function. Gradient function will help you get the gradient at any given point on the line. as we are going to see in other examples. But before we go to that, what you should know about differentiation is that sometimes you are told to differentiate, for example, this function y is equals to x plus 2, y is equals to x minus 1. First thing is that you expand the bracket. Before you differentiate, you expand. So you're going to have y is equals to x squared minus x plus 2x minus 2. So y will be x squared plus x minus 2. This is when now you differentiate and you say dy over dx will be equals to 2x, okay, plus 1. 2x plus 1. So sometimes you are given an equation to differentiate, but it is not yet expanded. So you expand first, that is when you differentiate. Same to simplifying this. You can be told to have maybe, what can you be told to have? Can even be told to have to differentiate to x, let me say x into x plus 2 over x. So when you're told to differentiate this, first of all, you do what? You simplify. You simplify. This can cancel this. So you remain with y is equals to x squared plus 2. So dy over dx will be 2x. 2x. So please, whenever you are given a complex equation, first of all, you can simplify it before you do what? You decide to differentiate. So that is much about the introduction to differentiation. So let us, yes, and now to test whether you've understood the importance of the differential or the gradient function, there's an example here. So you can be told the curve y is equals to ax cubed minus 3x squared minus 2x plus 1 has a gradient 7 when x is 1. So you're supposed to find the value of a. Find the value of a. This is why I'm saying you cannot cram mathematics, you have to understand. For example, we are told that the curve is this one, has a gradient of 7 when x is 1. This is why I told you that for you to understand this topic, you have what we call a graph. And this graph, I've told you that for you to know how it operates, you must get the gradient function. This gradient function, after getting it, you can get the gradient at any given point on the line. For example, here you are given x as 1, and you're told the gradient is this. When x changes, the gradient perhaps might change because you are seeing the nature of this graph. So when you are given the equation and you're given the gradient, you just say, you differentiate this in order to get the gradient function. The gradient function is what you equate to the gradient, because the gradient function is what gives you the gradient after substituting the point at which you are given. So your solution will be, you get the dy over dx for this equation, and that is going to be 3ax squared. You reduce, you pre-multiply, and then you reduce the power by 1, minus, this is 6x, okay, then minus 2. This one, you know why it doesn't appear in the differential is because it's like 1 x raised to power 0. So when you multiply 0 by this, it nullifies everything. meaning the resultant is 0. So there is no need of writing it here. So this one is called a differential or a gradient function. So because it is the one that gives us the gradient, and you already given the gradient at a point x is equals to -1. So we are going to equate this to this. Okay? So we are going to say 3ax squared minus 6x minus 2 is equals to 7. But then already we are given x as 1. So anywhere you see x, you put 1. So we're going to have 3a into 1 squared minus 6 into 1 minus 2 is equals to 7. This will give you 3a squared. Okay? So this is already 1. 1 squared is 1. So you already have 3a here, because 1 squared is 1 times 3a is 3a. Minus, this is 6 minus 2 is equals to 7. So 3a is going to be 15 and a is going to be 5. Simple. So this one is a question that majorly tests whether you know that the gradient function can give us the gradient when we are given a point. Okay? Yes, so that is it. So we can proceed now. So let us proceed to equations of a tangent. Equation of a tangent to a curve. To a curve. Now, class, this is what we mean. When we want to get the equation of a tangent to a curve, you already know how to get the equations of lines, and you can refer to our video in the link if you don't understand. This is what a tangent means. When you have a curve, like this, and you have a line that touches the curve at only one place, this line qualifies to be a tangent. That is very important, that a tangent touches the curve at only one given point. It is called a tangent. Okay? So when you are told to get the equation of a tangent, it means you are told to get the equation of that curve at a given point, because the tangent touches the curve at only one point. So that point is what you are going to use to get the equation. So because the tangent is a straight line, your answers will be in the form of y is equals to mx plus c, because these are lines basically touching the curve at only one given point. I hope that is clear. So when you understand that, then we are going to do an example so that you can understand what we are trying to say. So we have an example here. Let me write it here. In case this is a question, the equation of a curve is y is equals to 3x squared minus 4x plus 1. Then you are told to find the equation of the curve at a specific point. That one already tells you that you are getting the equation of a tangent, because a tangent touches the curve at only one particular point. So how are we going to do it? Number one, we get the gradient function. And how do we get it? We are going to differentiate this function. So we are going to say dy over dx is equals to, this is going to be 6x, that is going to be 6x minus 4. That will be our gradient function, meaning for us to get the gradient at any given point, we must use this function. Okay? Yeah. So for us to get the gradient, we are going to replace the value of x here. Remember, points are given in the form of x comma y on the Cartesian plane. So for us to get the gradient, we are going to get the gradient at this point when x is 2. So for us to get the gradient, we are going to replace and say our gradient will be 6 into 2 minus 4. Yes, what do you get? That is 12 minus 4, that is 8. So when you have the gradient as 8 at this particular point, and you have the point, umeshapewa, so you simply form the equation. And I've left a video in the description if you don't understand how to form an equation when you have a gradient and a point on the line. That is 2, 5, which you simply label x, y. Then you say the equation of a line is y is equals to mx plus c. Then you just replace. You have y as 5, then you have m as 8, you have x as 2, then you have c. So this is 5 minus 16 is equals to c. What do you get? What is c? Negative 11. So your equation will be y is equals to m is 8, x minus 11. Simple. Simple. Let us look at a second example so that you understand better. And so let us look at a case where, remember the other time we are given 2 points, that is x, y. But now let us look at a situation where you are given only 1 point. And the question reads, find the equation of the tangent to the curve y is equals to x squared plus 1, x minus 2, when x is 2. When you are only given 1 point, this is different from the first case. The other case we were given both points. But when you are only given 1 point, what do? You first expand the one that you have, then you replace the value there to get the point first. So we are going to do that, exactly that. So we're going to say y is equals to x squared plus 1, x minus 2. We expand this. You know how to expand. We're going to have y is equals to x cubed minus 2x squared plus x minus 2. So we've already expanded. So if we wanted to get the value of y, we just replace here. So you will help me there so that we get the value of y. Because for us to form an equation of a line, we must have the point x, y. So when we are only given x, we can replace in the equation in order to get the value of y. So you just say at x is equals to 2, y will be, everything you see x, you put 2. So this will be 2 cubed minus 2 into 2 squared plus 2 minus 2. I don't know what y comes to. Your y comes to 0. If you calculate that very well, yeah, your y will come to 0. So meaning our point, therefore, on the line will be 2, 0. This is very important. And it is different from the first example, because the first example we are already given the points. But here, you have to replace in the equation in order to get the value of y, so that you can then form the equation of the line. So we already have this. So the next thing we do, we're going to differentiate this to get the gradient function. Then we replace the value of x in the gradient function in order to get the gradient at that particular point. So we are going to say dy or dx is equals to, this is 3x squared minus 4x, okay, plus 1, plus 1. This is 1, yes, plus 1, plus 1. So this is the gradient function. So we replace the value of x in order to get the gradient. So what is our m? M will be 3 into 2 squared minus 4 into 2 plus 1. What is the gradient at that point? So you will get the gradient at that point as 5. So after getting the gradient function, for you to get the gradient at that particular point, then you replace the value of x in your differential or gradient function in order to get the gradient at that particular point. So you already have the gradient. you already have the gradient and you already have the point on the line. So forming an equation is easy because you're going to say the point you have is 2, 0 and the gradient is 5. So just say y is equals to mx plus c. This is x, this is y, and this is m. So y is 0 is equals to 5, then this is 2 plus c. So our c will be negative 10, yeah, because it will cross the equal sign, negative 10. So therefore, our equation of the line will be y is equals to 5x minus 10. Simple. That is how we go about it. So whenever you're given 1 point, ensure you replace in the equation in order to get the value of y. Then once you have the point, you differentiate the function in order to get the gradient function, and then for you to get the gradient at that point, you will replace the value of x. Please replace the value of x. And then once you replace the value of x in your differential, you're going to get the gradient. With the gradient and a point on the line, you can form an equation. That is simple. Yeah, so once we've known how to deal with the equations of a tangent, we are going to deal with equations of a normal to a curve. What is a normal to a curve? Class, a normal to a curve is a line that is perpendicular to so say this is your curve, this is your curve, very nice curve. Then you have a line here which we agreed is called a tangent. A line that touches the curve at only one point is called a tangent. Now a normal is a line that is perpendicular to the tangent. So when you understood our lesson on equation of a straight line, whose links are in the comment section, you will know what perpendicular lines mean. So this line here is what we call a normal. This line that is perpendicular, it meets the tangent at 90 degrees. So it is perpendicular. This is what we call a normal. So when you are getting a normal to the line, it means that first of all you get the tangent, and then for you to get the gradient of the normal, you're going to get the negative reciprocal of the gradient of the tangent. I hope we are okay up to there. So when you don't understand perpendicular lines, you can check the video on that on the comment section. So basically, a normal is a line that is perpendicular to a tangent. So first of all, you're going to differentiate your function, and then you get the gradient of the tangent. After you get the gradient of the tangent, you get the negative reciprocal of that gradient in order to get the gradient of the normal, and then you use the point given, which must be in the form of x, y. When you are given, it's okay. When you're not given, you replace the value of x in order to get the value of y at that particular point. To understand this, I'm going to do you an example. So let us look at this question. Now let us look at this example so that we understand how we get equations of a normal to a curve. So the question says, the equation of a curve is given by y is equals to x squared minus 2x. That is correct. So you are supposed to determine the equation of the normal to the curve at x is equals to 2. I said first of all, whenever you're only given 1 point, please replace this in the equation in order to get the value of y first. Because for you to form an equation, you must have a point, and a point on a line must be given by x, y. This is how we read points on a Cartesian plane. So if you only have one, you replace in this equation to get the other. So that is the first thing we are going to do. So we say at x is equals to 2, what is y? Y will be 3 into x is 2 squared. I'm replacing in this equation here. Minus 2 into 2. So what do you get as y? So 3 into 2x squared minus What do you get?
8.
We get it as 8. So our point is 2, 8. Well done. So the next thing we are going to do is to differentiate this in order to get the gradient function, and then we replace by the value of x to get the gradient at this point. So let us get the gradient function by differentiating dy over dx to be equals to, this is 6x minus 2. That is 6x minus 2. So we are going to say at x is equals to 2, let us get the gradient at that point is 6 into 2 minus 2. What is the gradient? Is it 10? 12 minus 2? 10. So once you get this, remember this is the equation of the tangent because it is the equation at this particular point, So it is an equation of a tangent. But you are asked for the equation of the normal. Remember the normal is perpendicular. Is perpendicular to the tangent. So for me to get the gradient of the normal, which is m2, I'm going to get the negative reciprocal of m1. So if my m1 is 10, therefore my m2 will be the negative reciprocal of that, which is negative 1 over 10. So because I have a point now and I have a gradient, what I can now do is to form the equation. I simply say y is equals to mx plus c. So what is my y? Remember this is x comma y. So my y is 8. My m is negative 1 over 10. My x is 2 plus c. So we're going to have 8. This will cross the equal sign. This is 1 over 5 is equals to c. So what is it? 8 plus 1 over 5. 8 plus 1 over 5.
41 over 5.
So we'll have 41 over 5. So your equation will be y is equals to m, which is negative 1 over 10 x, then plus 41 over 5. Cheap. So what you always remember is that the normal is perpendicular to the tangent, this point here. So for you to get the equation of the normal, after you get the m1, which you get by replacing the value of x in the gradient function, then you are going to say that for me to get the gradient of this normal, you get the negative reciprocal of m1. Then you replace with the point you are given and you form your equation. Correct? Now let us look at another example so that you better understand how to get the equation of normals to a curve. And the question reads, a curve is given by y is equals to 2x cubed minus 3x squared minus 12x plus 12. So you're supposed to determine the equation of the normal of the curve at the point 1, neg 1 in the form of y is equals to mx plus c, where m and c are constants. And so class, this is very simple because already you've been given the point, so you don't even have to struggle. What you need to do is simply to get the gradient function, replace at this point of x to get the gradient of the tangent, and then from the gradient of the tangent you will get, from the gradient of the tangent you are going to get the gradient of the normal. So we're going to differentiate this function here. So we're going to say dy over dx is equals to, that is 6x squared minus, this is 6x minus, that will be 12. Now we're going to say at x is equals to 1, because x is the value we have here. At x is equals to 1, what is the gradient? The gradient m will be 6 into 1 squared minus 6 into 1 minus 12. What do you get as gradient? What do you get as gradient? It is negative 12. So remember, this is our M1. For us to get M2, we get the negative reciprocal of M1, because what we are told is to get the equation of the normal, and we know that normal is perpendicular to the tangent. So the negative reciprocal gives you M2. So our M2 will be, it will be 1 over 12. 1 over 12, then 12. So with the M2 here and the point here, you can form the equation, because now you have the point as 1, 1, and you have the gradient as 1 over 12. You simply say y is equals to mx plus c, and then you replace, this is x, this is y, and this is m. So negative 1 is equals to m is 1 over 12, x is 1 plus c. So negative 1 over 12 is equals to c. What is c? Negative 1 minus 1 over 12. What do you get? Negative 13 over 12. So your equation will be y is equals to m, which is the gradient, 1 over 12x minus 13 over 12. As simple as such.